Firebase allows developers to get their apps working quickly, and Flutter does the same thing. But as it goes in life, trade-offs are everywhere. Sure, you can hack something together in a dash of enthusiasm, but this initial excitement will fade away as soon as you get totally lost in your own code. Flutter apps need structure that is easy to orient yourself in, testable and maintainable. It also wouldn't hurt if the way you architect your Flutter apps allows for adding new features without having a severe headache, especially with client-centric services such as Firebase Firestore. It's extremely important to keep your code clean. So let's do it by following the principles of domain-driven design in this tutorial series. Hello, welcome to ResoCoder, where you are getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. Before we hop into the explanation of what is domain-driven design and how can we apply it to our Flutter apps, let's take a look at what we are going to build throughout this tutorial series. We're going to build a pretty substantial app using Firebase Firestore and Firebase authentication, and it's going to be a note-taking app. So here we have a note of important things which we should do immediately. So after you like and share this video, subscribe to ResoCoder. You can then also learn from the written post, and we have just ticked off all of these to-dos. We can now save this note, and you will see that this note is now present here. We can untick something, although don't unsubscribe from ResoCoder, that's for sure. And when we untick these two to-dos, they're now going to be also unticked in this overview of to-dos. And also, if we go here to this last note and we update it, for example, let's say that we have already read Plato's Republic, right? We can also change its color to be red, maybe. When we do that, this last note will now be updated, which means it will be sorted as the first node right over here is now first in the list of all nodes. We can then also show only the nodes which are not yet completed. So because this first node is now fully completed, all of its to-dos are checked off. When we filter by non-completed, the first node will go away, and also this second last node will go away too. So this is what we can do with nodes. We can of course also add new nodes. And if we leave, for example, to do empty, it's going to say that it cannot be empty. So we need to input something in. The same goes for the node body. We cannot leave it empty because it's just going to provide us with an error message right here. All right, we cannot possibly have it empty because we are not even going to be able to save anything to the database unless the data is fully valid. So that's nice. And also we cannot have more than 3 to-dos. We're going to be otherwise prompted to activate premium. So yeah, the premium buying is not implemented, but yeah, you can, at least this premium upgrade message is implemented. And once we have all of the to-dos filled in, also the node body is filled in, we can select the custom color for the node, and this node will be added to our list of nodes. Awesome. So this is what we can do with the nodes. But of course, this app would not function without authentication because all of these nodes are persisted to Firestore. So we can log out from this app by clicking this button. And we're gonna be taken to the sign-in page where we can either sign in with Google or with an email and password, and we can also register. So again, you cannot leave the email and password fields empty. When we enter an email, resocoder.com and an invalid password, right? Sign in. It's gonna tell us that invalid email and password combination was entered. Also, when we leave the email to be something invalid, it's automatically going to say invalid email. And when we fill it in again to be valid, so resocoder.com, it's going to hide this error message. When we try to register with an email which is already registered, it's gonna say email already in use. And now when we finally sign in with the correct password, we are gonna be presented with the notes we had there even previously. And we can of course also sign in with Google with my @resocoder.com email. And we're gonna be presented with the same notes. So this is the app we're going to build. This was an extensive overview of all of this. We're gonna build it throughout this tutorial series. So make sure you stick till the end. And now let's actually go through what is domain-driven design, what is the big picture, and how this app is going to be implemented. The term domain-driven design may bring you shivers, and the same may be said about the term architecture, but actually architecture is something which is very beneficial to any sort of a software project you can take on yourself. That's because without proper architecture, your code will start falling apart. You will not be able to maintain it. You will not be able to test it. And overall, it's going to become one huge mess, which is pretty hard to clean up down the road. So you have surely built Flutter apps, or at least seen some Flutter apps being built with Firebase authentication and Firestore. And you may also have built some apps using a REST API, so you performed some HTTP requests. And even then, you surely did not put all of your request code into your Flutter widgets layer. I hope at least. You at least separated out your code using change notifier, or maybe you used block or even something else. So this means that even before you use some sort of an architecture, right? And what we are going to do in this series is that we are going to not use just some sort of an architecture, but instead we're going to use a serious sort of an architecture. And you can see this overview right over here. Also, I would highly recommend you to check out the written tutorial from the link in the video description, where you can find this full write-up of what I am about to tell you in a written form, and you can go through this at your own pace, because this first part of this tutorial series will be fully packed with information which will probably be quite new to you. So really, if you want to go through this at your own pace, take notes, highlight something, and understand this fully, go ahead and click the link in the video description and learn from the written tutorial. Also, you may have seen my Clean Architecture series on this channel, and over there we had some sort of an architecture. This one will be pretty similar, but it's gonna be also different. I'm gonna explain the differences in just a bit. But basically, you do not need to worry if you have not seen my Clean Architecture series, because it's not a requirement in order to watch this series. You can totally start fresh with this series, and you are going to learn everything you need to know as we go. So let's go over the basic things which are immediately visible in this diagram. So we divide our app into 4 separate layers. Those layers are called presentation, application, domain, and infrastructure. So you may be already familiar with the presentation layer, because that's what is usually meant by Flutter. Flutter really lives in this widgets layer. All of the other things are built by us, or they are just third-party libraries, but the Flutter widgets, Flutter SDK, is used only inside the presentation layer. We're gonna get to this layer in more detail in just a bit, But now let's move on to the next layer to just have a brief overview of it. So the next one is application layer. And you can see that we are using the term block here. And this is what I want to get to before we go into more detail into the separate layers. So do not worry if you just hate block and if you have declared it your sworn enemy. We're gonna use block in this tutorial series, but you don't have to. I will always explain if there are some differences for when you are using block and when you are not using it. For example, here, when you are using block, you are going to have states and events in the presentation layer, and you will have block in the application layer. If you are not using it, but you instead want to use something like a change notifier or a mobx store or whatever else, you will have a view model in your presentation and you will have use cases in your application layer. These are the only differences for when you use block and when you don't use it. You are probably already familiar with most of the terms on this diagram. So for example, here we have a user who performs touch and maybe even speech events. In our case, we're going to be only operating with touching on the screen. And this goes into the widgets, right? So usually you have some gesture detectors, some buttons and so on. And then basically you have events, or you call some methods on view models. You know about blocks. We're gonna get to use cases in a little while. But what's completely out of this ordinary world of Flutter development, that's this domain layer, right? Because yeah, you have some data sources, that's the usual stuff which you should do if you are a decent programmer. You are not going to put your data handling logic into the widget code. That's really bad if you do it. I hope that you don't. And also there are blocks, like most of the people are at least a bit familiar with the block pattern, but this domain layer, it just doesn't exist anywhere unless you have watched my clean architecture series. But even then, inside the clean architecture series, this domain layer looked a bit different. So what's up with this domain layer? Well, this domain layer is the absolutely most necessary layer and the most central layer of any app. It contains entities and validated value objects, which are held and sort of composed in those entities. And then it also contains failures. Without getting too much into the details just yet, let me just tell you that the validation you have seen in the emulator, so for example, the validation in the login screen that we cannot log in with an invalid email. So if we do not have the .com top level domain, we're not going to be able to sign in. It's going to say invalid email. And as soon as we add that .com in there, the error message will be gone. This value validation did not happen inside the UI. This validation happened inside a validated value object. It's a part of our domain layer. It's our business rule. And the business rule says that any string which should represent an email address has to have the top level domain. We are using a regular expression to validate an email address. And the same goes for password. We do not have just any sort of a string in the UI and that is only validated in the UI. No, we have a value object called password in our domain layer. And that value object's job is to make sure that it holds only values, string values, which are at least 6 characters long. If they are at least 6 characters long, everything is good. If we delete the characters, it's gonna say short password because there are not 6 characters, right? So this is the core distinction, the most important differentiator of this domain-driven design thing we're gonna be doing in this tutorial series, that everything which is a business logic is gonna be held inside the domain layer, and we are going to encode it into types. We are not gonna pass around strings, we are not gonna pass around integers. Instead, we are going to have them be wrapped inside a value object, which will validate them. So now that we have at least some sort of an idea about what these value objects are doing in our app, let's look at the entities. Entities are fairly simple. They just contain a bunch of validated value objects. For example, if we sign into our app with Google so that it's quicker, and we come here, this node is an entity, and this node holds multiple validated value objects. One of them is node body, because this node body has an encoded validation logic saying that it has to be not empty and it has to be maximally 1000 characters long. Then it has a node color, validated value object, and then it has this to-do list, which can have only 3 items inside of it, and every to-do cannot be empty, right? So if we want to leave this empty, we're gonna get an error message. That just cannot happen. Oh, and by the way, we can also, we can also delete to-dos like this. So that's also something which we can do. Nice. So this whole node is going to be held inside a node entity. And that node entity will be comprised of multiple value objects. Cool? I hope so. The domain layer is also going to hold any sort of a business logic which is central to our app. We're going to get a look at it throughout this tutorial series. The last thing I would like to tackle in this domain layer before we move on to other layers are these failures. As you know, exceptions are thrown around the app left and right. You don't know where they originate from. You don't know if you are gonna catch them. You do not have any idea like what to do with them because they can be flying literally from any side. And what usually happens is that you have to check the documentation of a method to find out which exceptions can this method throw. And then you have to have catch statements, multiple ones, and really just catch those pesky exceptions and hope that you didn't forget about anything. What if we could change this horrible situation by not throwing exceptions in our app, but instead by using failures, which are going to be joined into the regular flow of data. So just like you return integers from a method, or you return entities from a method, in our case, and validated value objects from a method, you are going to return failures in the same way. There will be no separate flow of errors and exceptions by throwing them. No, all of the exceptional cases are going to be returned from the method in a way that you cannot possibly forget to handle a failure and that you cannot forget about any case of a failure. And by the way, I really recommend you to check out the written tutorial from the link in the video description, because there you can really go through all of this information even more in depth and at your own pace. So we have just gone over the most differentiating layer of this whole architecture, and that's the domain layer. This is really the core of your app, and this domain layer is not gonna be dependent upon any other layers. There are gonna be no dependencies from the domain layer to the outside layers, but on the contrary, other layers will heavily depend on the domain layer in one way or the other. We're going to again get to the details. Throughout this whole series, you're going to learn everything. This first part of this tutorial series is really just a high-level overview so that you kind of know where we are operating, but I do not expect you to understand everything just yet, because yeah, there is really a lot to comprehend. And as I always preach here, the best way to learn is by building projects, but you also have to have some sort of a foundation to build off of before you start building projects, because yeah, otherwise it's going to be pretty bad. So I need to provide at least some kind of an explanation up front. So we have gone over the presentation layer. There is really nothing fancy in here. It's the usual Flutter stuff we are all used to. So you have states and events if you are using block, or you have your change notifier or states rebuilder or whatever you have. State notifier, the new package from Remy Rousselet. Whatever you have here, you are golden. This is the usual stuff. So we have gone over the domain layer and the application layer. Well, what is it? It holds blocks, which some of you may be familiar with, or it holds some use cases, which also some of you may be familiar with. You're gonna have use cases here if you do not wanna use blocks. And there are links in the written tutorial if you want to learn more about use cases. But as I said in this tutorial series, we are going to use blocks here. The role of the application layer is to orchestrate everything which goes on in the app. So you aren't going to find any UI code inside the application layer. Neither network code will be located here, nor any database code, nor like anything. The only logic inside the application layer is that it's going to take inputs from the presentation layer, in this case in the form of events which arrive in the block, and then it's going to decide what to do with those events and sort of call repositories to get some data from the outside world. It's going to instantiate validated value objects, right? Because block receives raw data, but we want to validate that raw data, those raw strings, so that we can have actually those nice error messages in the UI. So the instantiation of these validated value objects will happen inside the block or inside the use cases, whatever you want to use. In our case, the application layer, so the blocks, will manage subscriptions to the real-time data streams from Firebase Firestore, right? Because we need to manage those streams so that they're going to be disposed of when we close a route in Flutter, so that we do not get billed for unnecessary Firestore reads. So all of this management kind of stuff will happen inside the application layer, but nothing else. No business logic is inside the application layer. Business logic is reserved for the domain layer. The application logic holds something called, well, application logic. Its sole purpose is to orchestrate the flow of data around the app. We've gone over almost all of the layers, and what's left now for us to cover is the infrastructure layer. If you take a look at this, its closest representation among the other layers which we have gone over is the presentation layer. Because if you look at it closely, this infrastructure layer is at the boundary, right? It's at the outside of our app. And also the presentation layer is at the boundary of our app. Of course, the boundaries are different. The presentation layer interacts with the user, whereas the infrastructure layer interacts with APIs, databases, and the device sensors, like for example, location and accelerometer and so on, but still it's at the boundary. So what this means is that this layer can change pretty rapidly and tremendously. So we definitely want to keep this kind of tucked away, so that, for example, if we decide to change from SQLite database, for example, Moore, to something like NoSQL local database called Hive or Sembast or whatever you need, if we decide to change that, which is a pretty substantial change, we are not gonna need to change anything besides the infrastructure layer. Or actually, we are probably gonna only need to change the local data source. Everything else from the infrastructure layer up will be unchanged. And most importantly, this domain layer will be completely untouched. But let's go nicely bit by bit. As you can see, the infrastructure layer has really three core parts. It has repositories, data transfer objects, and then also data sources. Let me immediately mention here that we are not going to touch data sources in this tutorial series because we are actually not really gonna communicate with raw data directly. If you think about it, we have Cloud Firestore and also Firebase Auth packages from Google, or actually now from the community, unfortunately, because Google sort of decided to leave it up to the community, which is really unfortunate. But anyway, we have those packages which will communicate with the raw data for us. So the Firestore class from the Cloud Firestore package will serve as our remote data source for Firestore. So what we are going to do is to operate only with the repositories, and with the data transfer objects, the data sources are going to be kind of handled for us. So what are data transfer objects? Their sole purpose is to convert data between entities and value objects from the domain layer and the plain data coming from the outside world. Because the outside world will of course not have any sort of validated data. It's just going to be simple JSON, probably simple strings, simple integers and booleans. And we want to take that data and fit it into our view of the world, how we modeled it inside the domain layer. We do not care how the database structures the data. We do not care if the JSON response contains some additional fields, or if the JSON response is sort of split into multiple parts which we need to even join together. We do not care how the local database stores its data or how the location data is getting transferred from the device. We do not care about any of that in the domain layer. And it's the job of the data transfer object to contain the conversion logic for what we want to have in the domain layer. And the data transfer object will also in turn contain the data as it should be present in the outside world. Because of course, also when we want to send something as a request body to an API, we need to fulfill the databases or the REST API's expectations of how that data should be structured. So it goes both ways, conversion to raw data and also from raw data to entities, and validated value objects happens inside these data transfer objects. The last part of the infrastructure layer, which we haven't talked about yet, are the repositories. And these perform a very important task of being the boundary between the domain layer and also the application layer and the ugly outside world. Because if you look at this diagram closely, whoops, I just did something, all right. So if you look at this closely, what you can see is that the data transfer objects go over to repositories. Also, exceptions go over to repositories, and then from the repository comes out either an entity or a failure. So it's the job of the repository to catch all of the exceptions and return them in the usual flow of data as failures. So the only place where you are going to see try and catch statements is going to be inside repositories. All of our other code upside will be free of any try catch statements, hopefully, unless some exceptions happen in the widget layer, but that's not really usual thing to worry about. You usually do not catch any exceptions in the widget layer, but Should there be some exceptions in the widgets, you are gonna catch them in here, because as I said in the beginning, widgets are also at the boundary. So yeah, the boundaries basically handle any exceptions. But when it comes to data coming from an API, exceptions are all gonna be handled inside the repositories. And then of course, these data transfer objects, methods for being transformed into entities, are gonna be all invoked inside the repositories. So really ugly data will come into repositories, but the repositories will return pristine and nice looking data ready to be used throughout our app without any worries. And also, if you do not use Firebase Firestore, you are probably gonna need to cache data locally yourself, because as you know, Firebase Firestore does the data caching for you. So if you use your own REST API, the logic for deciding when to cache some data into your local database will happen inside the repository. This will hold the caching logic, but again, we are not gonna write that logic in this tutorial because we are using Firestore, and Firestore does that decision for us of when to cache and what to cache. Now you know at least a bit more about the whole domain-driven design thing, about the separation of our app into 4 layers, namely presentation, application, domain, and infrastructure layers. I know that this first part of this series was probably a bit too abstract to really get any actual idea of how we are going to build the app, but this information which you have gathered in this first part is really crucial, because without it we would not be able to progress forward at all, because you need to have all of these basic concepts settled. And again, I really recommend you to check out the written tutorial from the link in the description, because over there you can go over all of this information even more in depth and at your own pace, so that you can really absorb it to the full extent. So really just go there and yeah, because I cannot explain this information fully when I just talk about it, because I surely forget about something. So really go over the written tutorial and it's gonna be much better for you. And also, if you are serious about becoming a great Flutter developer who can build real apps for clients or at the job, go to flutter.education, and link is also in the video description, to get the top curated Flutter news and resources aimed at improving your app development career. And over there you can also subscribe to my mailing list to get the best Flutter resources delivered weekly right into your inbox without you having to do a thing. Just receive the news and be informed about what's going on in the Flutter world. And also, if you do not want to miss more tutorials like this, and also of course the next part of this series, which was so long time coming, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am just determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you to at least a bit understand the domain-driven design as it pertains to Flutter, give this video a like and also share it with our developers who are probably and surely and hopefully find it beneficial too. Leave a comment if you have anything to say, and see you in the next video of this domain-driven design plus Firebase in Flutter series.